Everybody, welcome to the Women in Technology virtual chapter meeting for May 2016. We have our speaker, Lynn Langit, ready to go. First, I wanted to let you know if you wanted to register for SQL Pass Summit 2016 in Seattle this October, you can register using the PassWit virtual chapter discount code that is shown there below. That we did send that out in our most recent newsletter. It's available on the wit.sqlpass.org website, and we've tweeted it a lot lately. So you should be able to find it. If you can't, feel free to send our chapter an email, and we'll get back to you with that. So today we have Lynn Langit, and she's going to present for us how to use her Teaching Kids Programming courseware. And of course she'll explain all of this once I turn the meeting over to her. Those of you who logged in a little early, there were a couple of you, probably heard Lynn and I talking about her work experience and what she's currently doing. And a little of my most recent woes with our team, but we're really thrilled to have Lynn here with us today. She sat on the Women in Technology Luncheon panel with Kathy Kellenberger, who is my co-leader of the WIT chapter several years ago. So Kathy reached out to her, or she and Lynn spoke about getting her started here with us today. So we have some upcoming webinars. Not all of these are going to be found on the WIT page, or I'm sorry, the links are found on the WIT page. Not all of them will be hosted by the WIT virtual chapter, so you won't hear me. You'll hear a couple of different people. We partner with other virtual chapters to bring you topics that are relevant to women in technology, or we help them promote female speakers. And so that's what some of these upcoming webinars are. So this is LaShawna Lewis, and she's going to talk about just her work history in IT and how she got started and what worked for her. So this one, I think, is actually, it's either the professional development or DBA fundamentals, but you can find the link on the WIT page for securing a SQL Server checklist. The description for everything that she goes over on this security checklist is very, very long. It's available on the web page. You're going to be very, very interested in this. I'm excited about attending this one. I'll be just returning from SQL Saturday Pensacola, but I'll be making sure that I'm in that one. 3 skills every junior DBA must know with Kendra Little. I think a lot of you are probably familiar with Kendra. So if you know somebody who wants to get started as a junior DBA, absolutely share this information with them to attend this webinar in July. Shabnam Watson is actually here in Atlanta. She'll be giving this same presentation at SQL Saturday Atlanta, May 21st. So I get to see it then. And then again in July. Evelyn Maxwell, and I actually bragged to Lynn about her. Evelyn Maxwell is 12 years old, and she just presented at a SQL Saturday on improving your PowerPoint skills. And there were a lot of MVPs and MCMs in the room, and they all walked away saying they had actually learned a lot about PowerPoint. So I'm so proud of her. And some of you may know her dad, Dave Maxwell. He's pretty prominent in the SQL Server community. So PassWit is on YouTube. This particular session will be available on YouTube later. So if you'd like, we're going to record it if there's details that you missed or something that you want later. Of course, this will be made available. I've referenced our homepage before, wit.sqlpass.org. You can find all of the webinars that I listed, some different resources, newsletters, things like that, and past webinars that we've hosted. The links are up there. If you join our virtual chapter, you get our monthly newsletter, which has anecdotes, stories, articles, different things like that. And of course, you can always follow our account on Twitter at PassWit, or you can follow the hashtag PassWit. So that is all of the information that I have today. I'm going to turn this over to Lynn. Lynn, are you ready to go?
Yes, I am.
Awesome.
So I'm going to show my screen and I will switch, and there we go. And how's my screen look, okay?
I can see it fine. It looks good to me on both of my machines.
Great, fantastic.
My organizer and my regular one. So.
Great, fantastic. Well, thanks to everybody for joining in. I'm Lynn Langit, and this is a talk about teaching kids programming. Teaching Kids Programming is a global nonprofit, part of the Nona Foundation. So all the resources and information that I'll be talking to you about and showing you are free, which is a hopefully interesting, great start to this. So in addition to being the director of Teaching Kids Programming with a group of mostly volunteers, I am also an independent cloud and big data architect, and I am a Microsoft MVP for the data platform. I'm also an Amazon community hero and a Google Cloud developer expert, so I do a lot of cloud and data work. But we're not here to talk about that. We're here to talk about the kids stuff. So I can get going here. The problem we all know, but you might not know the extent of the problem. And I take this through two lenses. The lenses are as technical people, and also as a lot of us are parents or know people with kids. I have a 17-year-old daughter myself. So it's interesting. I've done work interviewing teachers and parents for some of the big companies and for my own nonprofit. And as of last year, this is public research, not that I did, but 64% of parents, this is from code.org, think programming is as important to their child's future as English, math, science, and history. And this is U.S. Research. And all these pictures, by the way, are from camps that we ran. So this is one in San Diego. However, only 1% of kids in U.S. receive computational analysis education. And notice I don't say programming. And this is a particularly fun picture for all of us data professionals. This is part of a sister group that we work with. They're another nonprofit based in San Diego called TKP Labs. And they take our core computational courseware, our Java, and then they're building some new courseware around IoT and data. And what this exercise that you're seeing here is actually data visualization. And it was inspired in part by the meeting that I had with the guy who does Information is Beautiful at a SQL Pass event. He was a keynote speaker. So the TKP Labs people came back, I talked to them about this, and they came up with this activity. So that's why we say computational thinking, which includes programming, but it also includes working with data, as we well know. So what is being done to address this gap, and what does Teaching Kids Programming provide for you to possibly use in helping to address this issue? Of course, there's lots of legislation. I don't know if you guys are following the work of code.org, but they are actually, in addition to providing curriculum, working state by state to get computational thinking to be required in our schools, which is fantastic. However, even if that happens, the challenge is that there aren't trained teachers or curriculum. So there's a lot of grassroots movements. There's a lot of, Girl Develop It as an example, Black Girls Code, a lot of virtual groups and chapters. But one of the challenges with all these efforts is curriculum, and that's kind of the area where Teaching Kids Programming focuses. This is from an event up in Seattle with the Boys and Girls Clubs. One of the partners that we have is Boys and Girls Clubs. Regionally, we're actually working on a national partnership as well. So what can we do? How can developers, DBAs, data professionals help? This is a really old picture. This is when I started doing this work 9 years ago. Gosh, I was so much thinner and better looking, it's hard to see your younger self. And this is when I was a full-time employee at Microsoft. This is in the Microsoft office in Irvine, California. So what I did when I accepted the full-time role at Microsoft was I negotiated with Microsoft as part of a condition of my hire to basically get what is in some other companies, notably Google, called 20% time. And what that means is 20% of your professional time can be allocated to a project or an area of your choosing. And I actually negotiated and got that written into my contract at Microsoft to work on the Women in Tech problem. And the first manifestation of that was I started up a regional chapter of DigiGirls, which was a global Microsoft program, but was not in place in Southern California when I started. And so that was the beginning, really, of the Teaching Kids Programming work, because, as I was saying, even though we had a venue, we had kids, and we had corporate sponsorship, we had no curriculum. So I worked with the group here, who we still do work. It makes me smile just to see them. Some of them are full-time Microsoft, some of them are MVPs, some of them have gone on to other areas of industry. But we worked together and with kids, mostly girls, to develop curriculum. So as a first step, how can you get involved? I get asked that question a lot. Because I'm kind of a public person, I do a lot of speaking professionally, and I've been doing this work for 9 years. I get a lot of questions from technical professionals who say, I really want to work on this problem. What can I do? What is going to really make an impact? So I pulled together kind of the top 5 points just to get us kind of started thinking about this. So the first point, basically any sort of activity where you are working with kids and or their teachers is going to make a positive impact. And so you want to really think about what is your time allocation and who you are connected to. When I started, I worked through Microsoft, and I got teams together to host events for DigiGirls. And those started out as full-day events, and then they became summer camps as well in the Southern California market. Through Teaching Kids Programming now, I really don't do much event work anymore because we've moved the organization to focus on working with teachers in schools. And we actually have 4 pilots in the United States where we are working directly with middle school math teachers, and we've trained the teachers in our curriculum, and they are now using our curriculum as regular curriculum in the classroom. And I mean that's taken it's taken our group over 8 years to accomplish. So maybe that perspective is helpful to the listeners. Whether it's a single day event, after school, a series of ongoing events. Another program that we do is an hour a week with one school. We go over and we co-teach with the teacher, or it's an in-school program. Really, any sort of level of involvement is going to be helpful. Great curriculum is most impactful. One of the things I see people do that isn't as successful is they want to help, they want to be involved, but curriculum is kind of an afterthought. And so they get the venue, they get the kids, they get the funding, they do all that stuff, but then there isn't really a lot of thought put around curriculum. So I've seen some events and even some programs not be really impactful because the curriculum wasn't located, tested, the people who were going to teach it weren't prepared, the machines weren't set up properly so that the kids can actually do anything. So I think that's just really, really, really important, and it has become the sole focus of Teaching Kids Programming. Next sort of learning is to target the kids and segment the kids by age groups. One of the things that I've seen particularly in community events where maybe there's an ancillary event at a conference, like in a code camp or maybe even a regional or national conference, is a failure to segment kids by age groups. Like any kid can go to any class. And although that seems, to kind of have a fun element to it, it takes away from the success of the event. So what I have found is if you bucketize the kids into age groups and you apply certain types of curriculum, the events tend to be more fun and impactful for a greater number of kids. And the way I've grouped them is kids ages 6 to 10 will often respond best to visual programming or some kind of visual or tactile, whether it's robots or something like that. And I'm going to give you some examples from Teaching Kids Programming coming up in a minute or two. Kids from 11 to 14 really have the most success with pre-programming. They sometimes don't want to have what they call the cartoon or the little kid interfaces, but yet they are not as successful with full programming environments. And kids 15 to 18, they're ready for full-on programming. So just based on my experience teaching kids all over the world, keeping the ages pretty segmented around, and it's interesting because you always get, of course, the parents, and I'm guilty of this myself, saying, well, my kid, is exceptional, and my kid is 8, but they need to be in the full programming class. And you know, you want to really think carefully, especially when you have longer programs like after school or week-long camps, about making exceptions to those age rules, because I have found, you know, just lessons from the real world that can come back to bite you, basically. The next thing is teach what you love. You know, I am working with Courseware here around programming languages, but I realize that I'm speaking to an audience of data professionals, and of course I do professional work in the world of, you know, SQL Server and NoSQL and all kinds of databases. So as I showed in one of the earlier slides, where the partner group TKP Labs has done this work with data visualization, because that's what those folks that are running that love. Teach what you love. There's tons of technology, and although you may choose to use Teaching Kids Programming courseware, it might work for you. If not, you know, write your own or find some of your own in the domain that you're really interested in. Because kids, you know, they have a high BS detector, and if you don't really love what you're teaching, the event's not going to come off as solidly as what you'd hope. And my final tip in terms of experience in teaching and running events is try to get the kids to work in pairs. Professionally, I do pair programming, or I do what's called mob or group programming, because it's just a more effective way to work for the majority of my work, not all of it. And in my events, I try to run the events where I have 2 kids per computer, and actually 2 teachers as well. The sort of perfect thing is if one teacher's a man, one teacher's a woman, so we're modeling that, you know, it's technology teaching is not a gender specific, right? And I've gone to too many events where I've seen, you know, all guys teaching, and that's just not as effective when we want to make change in showing what is, you know, who does technology. In any case, one of the things when you're pairing is you want to explain and set expectations around the fact that the event, yeah, it's part of the event, because I've had parents in particular for summer camps be surprised and say, well, I thought my kid was getting his own or her own computer and this isn't as good. And actually there's quite a lot of professional research, academic research, that shows that the social aspect of pairing not only helps kids learn more, but is more inclusive, particularly girls, actually. There's a thesis this woman, Caitlin Kelleher, wrote around a platform called Storytelling Alice, which is the programming language that was designed for middle school age kids, where she did her graduate research on what would be effective working with middle school age girls. And in addition to some things in her platform and her curriculum, method, particularly around pair teaching, came out very strongly as being correlated positively. So anyway, those are my sort of top tips for success. So now let's get into the nitty-gritty of the resources. So as I was saying, I segment the age groups. Now I am doing the great majority of my personal work right now with schools with ages 11 to 14. But because I wanted to be inclusive, I'll talk about some things that I've worked with kind of outside of those boundaries and had some good success with. So I'll start with ages 6 to 10, and that is a visual programming. Now probably the most common thing that's used is MIT Scratch, and there's tons of resources out there for Scratch. And it's a great platform. I like it very much. But because this is a Microsoft audience listening in, and because Microsoft has something kind of unique and special that I've had a good success with, I wanted to talk about Microsoft CoDo and show it to you a little bit if you've not seen it. It works really great with the younger kids. 11 to 14, there is an older version of CoDo called Project Spark, which if the kids are visually inclined, they want to make games, that kind of stuff. It's a great platform, and I don't think it's enough play, so I wanted to share it with this audience. In terms of pre-programming, I'm going to actually demonstrate our offering in Java. Now, our core offering has a complete full first year, and it actually maps to the AP Java objectives for high school. So it's a pretty, I don't know how to say, complete curriculum, if you will, for coming from a nonprofit. I mean, it's not a commercial product, but we have 77 hours worth of curriculum. Now, that being said, it's all modular, so you can use it for an event. You can pull out, lesson A, lesson B, do it however you want to, because it's all free and it's all modular. So I have people using it for events. I have people using it for after school, 1 hour a week. I have people using it for Saturday events, for summer camps, and in school. Doesn't matter. I also, if anybody international is listening in, I've had people fork the repository on GitHub and localize it. I was just in Brazil, and I'm working with some Portuguese developers to localize the resources into that language so that it's accessible for kids. We also have an experiment out on Pluralsight. It's Teaching Kids Programming in C#. We took the first set of lessons, which is about an hour's worth of courseware, and there's about 5 lessons. And just the very beginning, and we ported our library from the original work, which was in Microsoft SmallBasic, into C#. I didn't list it on here, but the very original work we did was in SmallBasic. We have about 13 lessons there, and that's still out on the open source repository CodePlex, but we're not maintaining it, so I didn't list that. So you have a number of different languages. Kids ages 15 to 18, this is not actually part of Teaching Kids Programming, but it's a gal that we worked with. Her name is Katrina Owen, and she was teaching Ruby up in California, and her students were wanting to submit exercises and have her grade them. And so she created a platform called exercism.io for students to submit code, and it's pretty sophisticated. It's a coding dojos or coding samples that include test-driven development, and then the results are crowd mentor sourced. So in other words, they call it nitpicking. People can look at it, and I'll show you when we get there. And it really follows on nicely to what we're doing. And Katrina actually made some contributions to Teaching Kids Programming as well, so I always like to mention her work. So let's drill in a little bit here and go into CoDo first. Now CoDo is a free product, and it requires either a Windows machine or an Xbox. I think Xbox, it costs something. I think it's under 20 bucks. I'm not really sure. I don't usually teach it on the Xbox. But for Windows, it's free. Only Windows, though. And the idea with this is it is visual, and it's pre-programmatic thinking. So you can see here in this screenshot that you have these, the 1, 2, 3. These are when, do programming strips, if you will. So what's happening here, I'll just translate the first one. When, and you set it on an object. So the object here in the upper right is the CoDo, which is the character, and the character lives in a world. When the CoDo sees a tree, then he's going to move towards it. So what this does is, it's fun, first of all, and interactive and neat looking and all that, and kids are making games, is it gets kids in the mindset of what's called pre-programmatic thinking, so mathematical thinking, breaking down the logic into the when, do sequences. So we've had some really good success working with young kids with CoDo, and there's quite a number of resources. So let me show you what some of these look like. So let me go here and go to the resources. So first of all, CoDo is downloadable from CoDo Game Lab, and it's been around for quite a long time. Came out of Microsoft Research, and there are several school districts all around the world that use CoDo as part of their regular courseware. So you can see there's a classroom kit for educators. One of the curriculum directors for org, Pat Young-Pradit, is a school teacher on the East Coast, and he wrote a lot of this. I actually tech reviewed it because I was a Microsoft employee at that time, and my daughter and I were early beta testers of CoDo. Also, the CoDo team worked with the NASA people, and they did this Mars rover series that's in the samples in CoDo. Also, I did a course on lynda.com on CoDo for education, so that's another resource. You'd have to have a subscription for that one. But there's a whole bunch of resources around teaching CoDo. So I don't have too much formally in Teaching Kids Programming, because really this is a superset of an event for CoDo. Now over here you can see at what's called from Research Fuse Labs, you can see that you've got a whole bunch more resources over here. One thing that I think is kind of particularly cool for us technical people is, even though there's a visual representation of the language, there is an underlying you know, meta language, if you will. So you can print it out as text and get the kids, they can actually read what this says and they can debug it, for example, when they get more advanced, so that they can start getting ready to do pre-programming. So I had a lot of fun with CoDo, and I'm going to show you a couple more things. So I didn't install it because I'm on a Mac here. You can see here's the wheel. The design is really kind of beautiful. So the kids click on the wheel to build those when-do strips. And you know, you can do all kinds of things with it. You can use it for kids who really want to just create visual worlds, because it has brushes and paint, and you know, you can decorate the world and draw in the world and add objects. And then some kids, you know, really want to work with the programmatic aspect and make their objects do things. So I've done individual events, I've done groups, I've done what I call game-offs, where we get groups together. I've done where I put themes on a board and kids put Post-its basically. When I was in Hawaii, we did some work with the kids over in Molokai. It was really kind of cool. We had them make Molokai on CoDo. We had these little kids. It was pretty awesome. They made their island, and then they put various objects on their island and had them interact. So I've had a lot of fun with CoDo in events. I haven't really worked with it much in classrooms, but again, there's a lot of resources for it here. So that being said, let me talk a little bit more about our core offering, which is TKP Java. So first of all, why Java? I'm talking to a Microsoft audience here. The reason for the selection of Java, even though the original work was in SmallBasic and then we did a little bit in C#, is because if there is computational classes offered at all in our schools, and they're in high school, and they're in Java, and it's AP Java. Now, I do believe that that is changing with the efforts of Code.org and just sort of the general population understanding the importance of computational thinking. But what it is here now is Java. So the problem that we decided to work specifically on is this disconnect between this plethora of platforms for the really young kids, whether it's Scratch or Squeak or CoDo or whatever. There's really quite a lot offered for the young kids, and then nothing at the middle school, and then AP Java in high school. Also, I did some work with a woman up in Seattle who used to work at Microsoft. Her name is Ashley Myers, and really interesting. She was part of the Imagine Cup competition, and I think some of you guys are familiar with that. She and her colleague Ed, her name is Ed, even though she's a woman, actually were finalists in Imagine Cup. And so I got to know them actually at a Microsoft conference because they got to come as students, as students studying computer science. And then both of them got jobs at Microsoft. So Ed was an evangelist on the East Coast, an academic evangelist, and Ashley worked as a developer on the SharePoint team. So Ashley left Microsoft and she became a public school teacher in Seattle teaching computer science. And Ashley had taught TKP SmallBasic at events at the Microsoft campus and was really our lead, still is our lead TKP teacher up in Seattle. Well, when she was teaching in Seattle, she said that it was just this really big problem, which we knew from other people, but of course we knew her very well because we worked with her, that when kids would try to take Java in high school, they weren't prepared because they had only done Scratch or Squeak, and they would drop out. About 50% of the kids would drop out, and most generally the kids who would drop out would be the ones who were minorities or women or less access to technology, and it was just, she said it was just killing her. So we made this decision, at this point we were a nonprofit, to move forward with our work in Java. And what we decided to do is we decided to kind of make old new again. So there's been a bunch of work around Logo Turtle, which some of you are probably familiar with, and I'll show you in a minute, which is learning geometry through computation. This was done by this guy Seymour Poppert back in the 70s. And we decided to just take this approach and write a simplified API, simplified access to Java that had a visual feedback. So we started, and we had started in SmallBasic, and we translated that. And our goal was to have 40 hours of Java curriculum, and now we have 77, so we're doing good. The idea was to apply modern development practices to make it really fun. So we have pair programming, we have rapid feedback, we have working in pairs, we have mobs, we have this idea of koans and katas. It's kind of puzzle-based. And then the key component was, how would the teachers learn this? So what we decided to do is make all of our resources free and open source, so that, and put them on the web so that we could have maximum scale, given that we're a nonprofit and mostly volunteers. So we have about a 100-page book that's associated to our website. We have about 50 videos, most of which have been made by myself and my daughter, that show teachers how to teach this curriculum. And in fact, it seems to be working on a small scale, but it seems to be working because we have teachers, mostly math teachers, who have been charged to come up with something for programming, who are using our curriculum to teach themselves, and then they are teaching it in schools. We actually have a great success story to talk about. We have a school in Moreno Valley, California, where the math teacher, which is by Riverside, it's Los Angeles, was charged with creating a curriculum. And so it's a 6th, 7th, and 8th grade curriculum. And so in 6th and 7th, they do HTML, they do some web scripting, and in 8th, he wanted to get them ready for, Java in high school. So he evaluated various solutions, and he selected ours. He taught himself to program using our curriculum, and he took his class through our curriculum 3 hours a week, and then he is now using some Android curriculum from Google, and they're doing Android solutions. And the kids are actually, I'm at work today, they're actually coming over for a field trip this week, and they've written a lesson or a recipe, and they're going to come to my place of work where the programmers do not teach, or do not know Java, they know C# and other languages, and they're going to actually, the 14-year-olds are going to teach the programmers here Java with their lesson, which I think is a really fantastic success, and I'm really excited. And more importantly, the program has been accepted by the school board and is going to be a permanent part of this school's curriculum, and hopefully more in California and more in other states. So it's been a long time coming. We're very excited about it. So what does it look like? How do you get it? Well, let me show you. All right, so let's go here and, all right, so everything is indexed off of our website, and this is really just an index site is really what it is. You can see that we have Courseware, frequently asked questions, who's the team, and then donating to support the cause. So the Courseware, and this is really designed for teachers, school teachers. Teachers are the core audience of teaching kids programming, although parents, homeschoolers, professional programmers are certainly welcome to use it. So you can see that we've laid out here that each course contains several lessons and 1 to 3 programming topics. And we start with what the teachers wanted, which is called instructional design information. And this references into everything. Will have a screencast. So this is me talking about it. And then this references into our open source book. So this is our structure for our lesson plans. Basically, each course has these components, and I've been working on an ongoing basis with, like I said, my 4 pilot school teachers to try to learn how to speak teacher, basically, because I am not a trained K-12 educator in any way, shape, or form. And then this just really talks about, what is our methodology in terms of curriculum, how to get set up, so on and so forth. So that being said, do you have to read all the stuff if you want to use our curriculum? Well, it would be great if you did, but if you don't, you can just start with lesson 1 here, and lesson 1 just gets started, and this is like a 10-minute video of myself and my daughter teaching one of the lessons, so you can actually see how it's taught. We model it, and then here is the teacher resources. And again, because the school teachers wanted this grid We have this grid consistently in every course, which basically tells them, as a school teacher, how would I prepare to teach this? So you install the courseware, you read the lesson plan, you do the recipes or lessons yourself, look at the concepts PowerPoint, you work with the keyboard shortcut sheet, and then there's a written worksheet as well they can use for grading if they want to. This links into the answers, and these are over in GitHub. Only the teachers have the answers. So this links into the actual answer. So that's kind of the teacher side. So you might say, well, okay, how do I get this? Well, over in GitHub, we have an organizational repository. And again, it's all indexed through our site. But really how you would physically get the software is you go to the source and then you install it either on Windows or Mac computers. So we have an installation guide here. And what it physically consists of is a Java file, a compiled Java file or a jar file, which has the lessons, and a set of the settings in Eclipse that makes Eclipse look more simple. Basically reduces buttons and menus and things like that. And so we have detailed instructions on how to do it here, and it takes about 10 minutes to download and install properly. Now, because many of our schools have they don't really have the time or the technical sort of bent to install software, we have a pilot where we are working with a company called Codenvy, and I'll show you since you guys are technical and you'll be interested in this probably, to do a browser-based IDE. So this would run on any browser, and it would also run on Chromebooks, which more and more schools are getting. So this is in a beta form, but you're welcome to try it out. But do know that it's a beta form. So how it looks is basically, I'll just click it and turn it on here, is it will spin up an environment, and I'll actually code with it in just a minute here. And what it does is it's a website basically, and it is pre-populated with our jar file, with our Java file. Now Codenvy has a free tier, and it also has a premium where you buy compute time. From a technical point, it's Docker containers that are running on Amazon, but also Codenvy is installable. So it could be installed on virtual machines, either on-premise or on Azure or any other cloud. So go here, let's see what's here, and let's see what looks like it's going to run. So it thinks it's going to run Simple Square. Okay, so I'm going to go to Simple Square, and inside of here, the methodology of our teaching is, because we're that bridge courseware between Visual and full Java, is we have two languages. And I have actually a background in linguistics, and it kind of shows in the way we implemented. One is this meta comment language, which is a stylized English, and then two is the way we wrote the API. And we purposely wrote the API to be very close to the stylized language because, again, we're trying to provide that bridge before you go into full-on programming languages. Also, we want to have rapid feedback. So you see we have line numbers here, but we also have line numbers here. And the reason they're different is because you want to code in order so you can see it. So let me tell you what we're talking about here. So for the kids, we use the Socratic method for teaching. We would say, read the English on line 8. If I was the teacher, and the kid would say, show the tortoise. And I would say, okay, what's the noun? And they would say tortoise. And I would say, okay, type TOR. And then I would say, type control space. And then we really try to teach use of tools. And then I would say, press enter. And I would say, in English, we separate our words with spaces. And in programming, we separate them with dots. So type a dot, and what is the verb? And the kid would say, show. And then I would say, okay, we want to do control space because we want to get a list. And then we always want to guess. And we want to just start with the same thing. And again, this is instructional design. The very first line of every recipe is almost exactly the same because, again, we want the kids to be successful and kind of make it an easy path, because learning how APIs is hard, so we are providing that bridge, and then we diverge from that as we're teaching the new concepts. Then we'll say press enter, and then we'll say, hey, it's not quite done. In English, you end your sentences with a period, and in Java, you end them with something else. Pass your mouse over the little error, because you always want to read the red part, and ask the kid, what should you put there? And then semicolon, okay? And then we want to always run it when we have completed a line, and this is a very important part of our curriculum design as well, to make it fun. One of the things that we saw, just as an aside, when we were looking at what other people were doing with teaching kids coding, is they were like putting up all the code and having kids copy it, and the kids had no idea what it was, and it just was not good. And then if they missed a semicolon or something, they were kids had no idea. They weren't learning; they were just copying. So now this is a little bit different than having it on-premise, because what this is doing, I'll just tell you technically while it's spinning up, is especially the first time, it's actually spinning up separate Docker instances, because this is a professional adult editor that we've special made for kids here, and you can see all the Docker here. Basically, it separates the code instances from the run and build instances. So down here is where we actually see the preview. And what this does is this has a Java machine, basically, and it's a window into the Java machine on a browser, which, an interesting thing. It's a virtual machine, if you will. So now we're going to stop that, and then we would say to the kids, okay, we've translated this, so now we want to get rid of this line because we successfully translated it. Now we want to go to the next line, and we're going to do a control space, and we'd say to the kids, okay, what's the noun? Or read it, move the tortoise 50 pixels, great. What's the noun? It's a tortoise. What do you type? T-O-R. And then again, we don't tell them to type tortoise. We say, what do you type? It's actually really, really important. We do controls, and then we'd say, how do you get the rest of it? And they'd say control space. How do you, what do you do then? Press enter. And then how do you separate your words? I mean, I'm obviously doing this faster because of the webcast, period. And then how do you get that list again? Control space. And then what should I type? What's the verb? Okay, I'm going to guess M. Oh, there's move. Awesome. Okay, so let me put move. All right, what is the length in pixels? Okay, let me just put 50. And I'm going to do this. And then I'm going to run it again. Now, obviously, using the browser-based version requires fast internet. And so that's why we are supporting both the installed version, which I'll show you in a minute, and the browser version, because some people in places that don't have fast internet want to use this courseware. So we have both. So now we're ready to go. So now we can go out here, and now we have, yay, he moved. So this is, like I said, this is kind of future direction, but we really, really are moving towards this because we heard from our schools that more and more schools, frankly, are getting Chromebooks, and in the U.S. in particular, where we're focusing, and they just don't have the resources to install. Plus, it makes updating when we want to update our software much easier because we can just update sort of the source. And then something also really interesting, especially for this audience, is we can hook into events in this environment, and we can collect behavioral data around the usefulness of our API, and we can use the data in aggregate to find out like where kids get stuck, for example, and then ultimately we could actually probably provide customized implementation. Now this is far down the road, but this is kind of the dream and future of this, because like for example, once we could know where the kid was and how long they were on a certain aspect, I could just go to the next one here and I could say, all right, the kid is going really fast, they understand that this is turn, and this is really great, and then we could say 90, really, really fantastic, and they should run it each time, but for sake of time, I'm actually not going to do that. And then we could say, all right, now we want to change the line color here, so the kid is going to say, okay, great, that's fantastic, and then the kid doesn't know what to do. They're stuck there because they go control space and they don't see change the color. Now this is done actually by design. This is where the API starts to be a little bit different semantically, And so what they're going to get to is set pen color. So we're going to go in here, and then a couple other things to show you are we have written documentation for everything. So you can see here's an example, which is similar but not the same. And so the kid could copy and paste it, but they wouldn't exactly get what they need because it's supposed to be blue. Do you know what I mean? So let's say they're exploring this. Then they're going to go control space. And they're going to go blues, dot blue. And then they're going to get where they need to be. And we need to add this. And we have to get the appropriate one here. So we're going to type in pen colors. And there we need to get this. And the technical reason is we have to import it. So they have to actually go through the process to get this to work properly. And then you can go here and you can see that we've also put, fun icons and sort of Easter eggy type things in to get kids to work with our documentation because we want to teach good habits. So just to be complete, I'll show you what this looks like in Eclipse, and I'll show you a little bit more about abstraction. So here's the same thing in Eclipse, and right now if I run this, I don't really have anything other than just sort of setting the horizon going on and setting the window frame. But this is a demonstration recipe. So draw a red square that's 50 pixels per side with a line that's 2 pixels thick. So, and the tip here is to use the tortoise. So what we've done is we've created some abstraction methods so that you can quickly demonstrate, and this is more for teachers actually, on how we abstract. Because for kids this is a little bit high level, because what's actually here is quite a lot of abstraction in terms of what's going on under the hood. And of course all the source code, I'll use a random color here, is available, so for the teachers they can go back and they can look at it, which they often do. Let's go 20. So now we've got a shape, and we want 50 pixels per side. Oh, and it should be red. I just made it random with a line that's 2 pixels thick. So I'm coding like a kid now, where I don't actually read the instructions. And there we've got, okay, what happened? We've got this shape, and why does it look like this, and what would it take to do this? And this is kind of, the secret sauce, basically, of our curriculum, which is abstracting out all these steps. Now, oftentimes, very appealing to math teachers because, they can integrate this with their math lessons. That's another use of teaching kids programming curriculum, where they just integrate it and have the kid go back and say, okay, what happened with this draw shape? Where was the 5 represent? I mean, this is obviously for younger kids, but you can kind of see where that might work. Just to give you an idea of the breadth of the curriculum, here we've got our various sections, and you can see we start with for loops, and we teach methods, and we teach conditionals, and we have a mastery or check lesson. We teach recursion, we teach model view controller, we teach object instances, we also teach advanced loops in this section, eventing, and in the final we teach test-driven development. We actually truly do. We teach test-driven development to teenage or preteen kids, and they get it better than parents sometimes. So what kind of results have we had? How have we been able to have success, and what's possible basically? We're a really small group of volunteers. It varies because people kind of drop in and drop out, depends on what their professional work is, but we go between 4 and about 10 people, and we've had over, personally, the core team has taught more than 4,000 students worldwide, more than 70 teachers trained, and we have these 4 key pilot programs. Based on looking at Google Analytics, it looks like our courseware is being used in 16 states and 10 countries. I'm really excited. If anybody's on from Australia, I'm heading over to Australia this summer, and I'm going to be teaching over there. And I was there at Tech Ed 4 years ago, and I'd really, really like to work with some school teachers there because I know that they're starting to require computational thinking in all grades, and I'd love to launch teaching kids programming in Australia when I'm there. But it's, it can be pretty impactful is really the point. And not only in terms of the reach, but also in terms of the how impactful we can be. We have our first graduate, and boy, she did good. Her name is Genevieve L'Esperance, and she's from Canada. She's now 23. When she was 16, she was introduced to programming via Teaching Kids Programming. At that time, it was SmallBasic. And she was very inspired. She wanted to be a biologist her whole life, and she knew she would have to learn programming. So her mom was a Microsoft partner, and she introduced Jen to me and the team, and we taught her TKP SmallBasic. She is very extroverted, and at 17 through 20, she actually taught events for us. So, you know, she's strong stuff, this girl. And she actually keynoted a conference when she was 17, talking about teaching kids programming. So she taught quite a lot of events around the US and Canada. 19, she decided to major in comp sci and bio at McGill in Canada. 21, she had an internship at Microsoft Research. And very, very happy to say, at 23, she is a software engineer at Pivotal Labs in Santa Monica and doing fantastic. And she's the first to say that if she had not been introduced to programming at that age, she would have never considered this a possibility. So she's a really, really exciting success story. And if any of you want to talk to her, she loves to talk to people who are interested in this. So we want to have more. We want to have more. So again, how can you get involved? Best practices are partnering. One of the things I find that technical professionals do when they first want to get involved in teaching kids is they take on too much and then they can't really do it all. So, you know, do the thing that you can do that the other folks that you'll be working with can't, which is be the technical person. So as tempting as it is to do everything, you know, set up the event and da-da-da-da and talk to the parents and all that, I would say don't do that. And again, this is based on my 9 years of experience because it's really easy to burn out because it's a lot of work. So partner with nonprofits and schools who don't have curriculum because there's lots of, you know, Boys and Girls Clubs is a great example. Almost every city that we go to, Boys and Girls Clubs wants to work with us. So I think basically almost any Boys and Girls Club you could talk to. And if you have, you know, these other organizations like I was mentioning earlier, Girl Develop It or Black Girls Code or any of these other national organizations, just call them up and go, I'd like to volunteer. And I know they would be thrilled to get somebody who's technical because they're always challenged with that. So don't do that part. Let the nonprofit get the room and the computers and get the, you know, the parental consent and get the kids and all that. Just work on the teaching part. So in terms of the teaching part, I think it's best if you look at the courseware that's out there first because you can kind of see what's come before you and decide what you like, and if there's anything, whether it's CoDo or our stuff or, you know, some Scratch stuff or whatever's out there that you like, use that or a modified version because it's hard to write courseware. It's really hard and takes a lot of time. But if you don't, if after you're doing some events and you don't find courseware you like, it is possible. We've done it. You know, write some. If you love, you know, data stuff and there's not courseware on it, write some. Make sure you test it with kids. That's a key tip because, boy, we learned a lot. We thought we were quite cool until we took some of our courseware out and taught it to kids, and they'll give you really quick feedback, really honest. And work with your school teachers. Our school teachers need our help. They are scrambling. They have a very hard job already, just being a teacher, and they are scrambling to find high-quality technical courseware. So anything that we can do to help them is really going to allow us to affect the change at the scale that is needed.
So Lynn, let me interrupt you really quickly here. One, we have just a few minutes left, but while you were on the topic of teachers, I did get a question earlier asking how you got teachers to listen to you. That one of our viewers, he said he's curious to hear about this, that he finds teachers are guarded.
Yeah, okay, I'm so glad that question was asked. You know, a couple things. First of all, I've done a lot of research in this area, and where the pressure is coming first to get technology into middle schools is in the charter and private schools because they want to differentiate themselves through technology offerings. And that might not be what we want to hear because some of us would really, you know, prefer to work with underprivileged kids who usually don't get to go to those schools. But I will say that I've had really good success. One of my 4 pilots is a private school, and they're a national chain, and oh gosh, we've had such good success with them and so much feedback. So, you know, you have to go where you're going to have an impact. And I'll also tell you on the flip side, we had a colossal failure with a public school in an urban district for that very reason. So working with teachers is really tricky. So first of all, go for the low-hanging fruit. So if you've got connections to privates and charters, it's going to be easier. In terms of public, I've had the most success when it's teacher to teacher. That's why I'm so excited about this Riverside, California success, because this teacher found us through our website. And I didn't even know that what was going on until I looked at some of our resources and saw there was all these accesses from the Riverside School. And I kind of back researched it and contacted him. So he's been talking to other teachers and his colleagues, and it's been kind of a snowball effect with the schools in that district. I know that feeling, which is the teachers say to the technologists, you don't understand our world, and in fact we don't. So those are my 2 tips. One, privates and charters, and the other one is if you be organic, and if teacher discovers or works with you or sees you teaching, that's been another one where teachers would come to my event and see me teaching. You don't talk about it, you actually stand up there and teach, and teachers have respect for other teachers, and then they'll talk to you. So, okay, so let's see here. Okay, so that's teaching kids programming, and oops, let me go back. So yeah, I'm pretty much getting to the end anyway, so yeah, and I'm almost out of time, so that worked good. So I appreciate those of you who have been hanging in there listening, and you know, I hope that I gave you some useful information. I love to, I care passionately about this topic. My Twitter is Lynn Langit, L-Y-N-N-L-A-N-G-I-T, and you know, any feedback, any questions, you know, I think that we need to work to make a better environment for our kids, and so that's, you know, that's why we do this. And anybody who wants to join and do it in any way, I'd be happy to collaborate with. So with that, I think I'm going to wrap it up unless there's any questions, and really thank the WIT chapter for inviting me.
We were incredibly pleased to have you. Thank you very, very much for doing this. So I have 2 questions left, and one I'll go ahead and answer. Several people asked if this session would be recorded, and the answer is yes. It'll be recorded. It may take us a couple of days to get it uploaded to wit.sequelpass.org. There's a link at the top for meeting archives, so this will be there. Liz, do you want to make your slide deck available for us?
Yes, it already is, so let me show you where it is. And I can actually tweet it as well, but it is right here. It's on LinkedIn. So it's just under my LinkedIn, under Teaching Kids Programming, but you can just look at me and you'll find it. It's the one I just posted. So.
Okay. And the last remaining question, and I think I probably could have answered this one, but it'll be better that you do. And he asks, why do we want to teach kids programming? Won't programming be so different 20 years from now? And won't our old ways burden their minds?
Oh, I'm so glad. Yay, what a great question. Because this is so perfect for data people. With the explosion of big data coming, programmatic thinking, and which is really mathematical thinking, is going to basically be the key to the people who are making things or just consuming things. And I want our kids to be making things for our world. So the concise answer is you learn programming, you learn math. And as our world becomes more data-driven, more people need to learn math. And I'll tell you very specifically to end. My own daughter, who's been doing this since 8, tested out of calculus, the AB calculus, and she went to BC because I am fundamentally believe because she knows how to program. She doesn't even actually like programming, but she knows programmatic thinking because you know, living with me, you're going to get this by a side, basically.
I thought earlier you referenced it's important to teach kids computational analysis, and I know that there are some countries that actually start teaching kids logic in elementary school before they take math.
Yes. Well, Finland, which has one of the best school systems in the world, is requiring computational thinking K through 12. So So I think it's more than programming is really another way to answer it. I think that it's numeracy or mathematical literacy. It's an aspect of that.
Awesome. Okay, unless I have any more questions pop up in the next couple of seconds, I'm going to call it. It's 5 o'clock now, Eastern. I don't know where all of you are located. Thank you, Lynn, very, very much for your webinar today. We really appreciate it. Look for this recording. Share it with whomever you like. Follow PassWit on Twitter, and you'll find, I'll tweet the link there. If you registered for this event, you should also get a follow-up email that gives you this information. And I guess that's all we had for today. No additional questions have come in. So thank you very much, everybody, and have a great day. And happy Mother's Day to those of you that are mothers on the call.